Hi, the topic of this video lesson is definition of a numerical function, domain of function and range of values. We have already faced various functions, but now we will introduce a stronger concept. Let's consider some numerical set large X. And let's suppose the sum rule f is given before the elements of this set, according to which each element of large X, each element of small x, large X, some number y is assigned to. Then it is said there is a numerical function y equal to f from x on the set X. X is independent variable here, or an argument. F is the rule itself, or a function. Y is the value of that function. For example, y is equal to x squared. X is independent variable here, and square is the rule according to which it is matched. That is, the number 2 is put in compliance with the number 4, number 3 with 9, and so on. All possible values of the argument x, that is, a numerical set large X, is called the domain of the function and is usually denoted by d from f. Let's take a look at an example. Let's suppose we have a function y is equal to the root of x squared minus 4x plus 3. It is required to find the domain. That is, we need to find all possible values of the variable x. The domain in this case can be denoted as d from y. The expression under the root must be non-negative, as we are going to keep the root there. So the domain is determined by the solution of the inequality x squared minus 4x plus 3 greater than or equal to 0. Pretty simple inequality. If we solve it, then we get x belongs to from minus infinity to 1, and from 3 to plus infinity. This means that the domain of this function will be just the same, this interval, from minus infinity to 1, from 3 to plus infinity. Let's consider more examples. Let's suppose we have this function, 1 by x squared minus 4x plus 3. It is required to find the domain. This function is defined by any value of x, except cases when the denominator is 0. We already know that the denominator turns to 0 at points 1 and 3, so the whole number line will be the domain, except for points 1 and 3. It can be written as follows. D from y is the set of values of x from R, such that x is not equal to 1, and x is not equal to 3. Let's consider another example. When y is 1 divided by the root from x squared minus 4x plus 3. In this case, in order for the function to be defined, the root value must be greater than or equal to 0. And it must be strictly greater than 0, as root is in the denominator. So the domain can be found from the solution of the inequality x squared minus 4x plus 3 greater than 0. We already know the solution to this inequality as well. Then d from y will be from minus infinity to minus 1, no longer inclusive. From 3 to plus infinity. Let's introduce the concept of the domain of a function. Let's have a function y is equal to f from x. The domain of this function is all the values that y takes. These can be denoted as e from f, or much less it is denoted as e from y. Let's take a look at an example. Let's have a function y equal to root from x. The domain in this case, d from y, will be the interval from 0 to plus infinity. But what will be the range of values? Since we have this root and the root is a non-negative number, then e from y, the minimum value, is 0, and then y will increase indefinitely with the growth of x. So the range will be from 0 to plus infinity. The range of value is often easy to see on a graph. Let's draw a graph. The graph of the function y is equal to the root of x. Looks like this. Then we can look at the range of values along the y-axis. How does it change along the y-axis? The minimum value is 0. The maximum value will be unlimited when increasing. Therefore, the range in this case will be from 0 to plus infinity. Let's take a look at another example. Y is equal to x squared minus 2x plus 3. We need to find the range of this function. Since this is a graph of a parabola, let's find its vertex. Let me remind you that the vertex is found by the formula x0 is equal to b by 2a. It will be 1. To find the coordinates of the vertex, we will substitute this 1 here. 1 minus 2 plus 3, that's 2. So this is a parabola with vertex coordinates 1 and 2. Let's draw it. We mark points 1 and 2. And here is a parabola with branches directed upwards. Then we look at the y-axis range of values. We have the minimum value at the vertex, and the maximum value is not limited. So in this case, the range of values e from y is, the minimum value is 2. The maximum is not limited, plus infinity. This video lesson is over.